In 1959, a man named Arthur Samuel taught a computer to play checkers.
Not by writing the rules of checkers.
By letting it play itself thousands of times until it figured them out. That was the first time a machine learned something nobody told it.
That idea 60 years later is running your bank, your Netflix, your hospital.
This series is called Machine Learning from Scratch. No fluff, no skips. We go from zero to building real models.
But before a single line of code, you need the mental model.
Because if you don't understand what ML is actually doing underneath, the code is just magic you copy and paste. That's not learning.
This episode gives you the foundation. Everything else builds on it.
Let's start. So what exactly is machine learning? Here is the definition that actually matters. Machine learning is a way of programming where you give a computer examples,
and it figures out the pattern itself.
You do not write the rule. You show the outcome. The machine finds the rule.
That one sentence is the entire shift.
Traditional software. You write, if income greater than 50K, approve the loan. Machine learning. You show 10,000 approved and rejected loans.
And the model learns what approve looks like on its own.
Same goal. Completely different method. Let's make that comparison concrete. Traditional programming. Data plus rules goes in, answers come out.
Machine learning. Data plus answers goes in, rules come out.
Read that again. The inputs and outputs are swapped. In normal code, you write the rules. The computer follows them.
In ML, the computer writes the rules. You just show it examples.
That is why ML can solve problems where the rules are too complex to write down. How do you write a rule for, is this a cat?
You can't. But you can show a model 10 million cat photos.
And it will figure out what a cat looks like better than any rule ever could. Machine learning has 3 main types. Let's do each one properly.
Type 1, Supervised Learning.
Supervised means the training data is labeled. Every example comes with the correct answer already attached.
Email, labeled spam or not spam.
Photo, labeled cat or dog.
Loan application, labeled approved or rejected.
The model studies these labeled examples and learns the pattern.
Then you give it something new with no label and it predicts.
This is the most common type of ML in industry today. Regression and classification both fall under supervised learning. Predict a number, that is regression.
Predict a category, that is classification. Type 2, Unsupervised Learning.
No labels. No correct answers. Just raw data. You give the model 1 million customer records, no categories attached.
And you say, find the structure yourself.
The model discovers groups nobody told it to look for. Maybe customers split into price-sensitive, brand-loyal, and occasional buyers.
Nobody told the model those categories exist.
It found them from patterns in the data alone. This is clustering, one major branch of unsupervised learning. Another branch is dimensionality reduction, simplifying complex data.
Reducing 1,000 features down to 2 so you can actually see the shape. Type 3, Reinforcement Learning.
This one is different from both. No labeled data. No clustering. Instead, an agent, an environment, and a reward. The agent takes an action. The environment gives a reward or a penalty.
The agent learns to take actions that maximize the reward over time.
Think of it like training a dog. You don't explain the rules. You reward good behavior, penalize bad. Eventually, the dog figures out what good means. AlphaGo, the AI that beat the world champion at Go, used reinforcement learning. Modern robotics, self-driving cars, and game-playing AIs all RL. We won't go deep on RL in this series, but you need to know it exists.
Now, the question everyone skips. How does a model actually learn?
Not in vague terms. Mechanically, what is actually happening? Step 1. The model makes a prediction. It is almost certainly wrong. Step 2. We measure how wrong it was. That measurement is called the loss. Step 3. We use the loss to nudge every parameter in the model just slightly.
That nudge is called gradient descent.
Step 4. Repeat. Thousands of times. Millions of times.
Each pass through the data is called an epoch. After enough epochs, the predictions get good enough to be useful.
That entire process is called training.
The final set of learned numbers inside the model are called parameters or weights. Training sets them. Inference uses them. So where is this actually running? Right now. Today.
Netflix. Every recommendation you see was predicted by a supervised model.
Google search. The ranking of results ML. Your credit card. Every fraud detection decision ML in milliseconds.
Medical imaging. Models spotting cancer in scans with radiologist-level accuracy.
ChatGPT, Claude, Gemini, deep learning built on top of supervised training. Spam filters. Ad targeting. Autonomous vehicles. Voice assistants.
And this is 2025. In 10 years, far more.
The question is not whether ML will affect your field. The question is whether you understand it when it does.
Let's be honest about something most tutorials skip.
Machine learning is genuinely hard. Not impossible, but hard.
Challenge 1, data quality. Garbage in, garbage out. A model is only as good as the data it learned from.
Challenge 2, overfitting. The model memorizes the training data. It performs perfectly in training. Falls apart on anything new.
Challenge 3, the curse of dimensionality. The more features you add, the exponentially more data you need. Challenge 4, interpretability. You often can't explain why the model decided what it did.
These are not obstacles to avoid. They are things to understand and work with.
This series will teach you to handle every one of them. Before you write a single line of ML code, own this mental model.
Machine learning is a function approximator.
You have inputs, you have outputs, and somewhere between them, a pattern.
ML finds that pattern from data alone.
Your entire job as an ML engineer is to give it the right data.
In the right form, with enough examples, and let the math do the rest. The algorithm is not magic. It is a machine that adjusts numbers until predictions improve.
When your model is bad, you fix the data, the features, or the training setup.
Almost never the algorithm itself.
That mental model will save you hundreds of hours of confusion. Hold on to it. Every episode in this series builds on top of it.
Here is exactly where this series goes.
Episode 1, this video. The mental model and the types.
Episode 2, setup. Python environment, libraries, first line of code. Episodes 3 and 4, the math that actually matters.
Linear algebra, probability, gradient descent, taught practically.
Episodes 5 and 6, supervised learning. Regression and classification. Real algorithms. Real data. Real predictions.
Episode 7, model evaluation. How to know if your model is actually good.
Episode 8, feature engineering. Making raw data ML ready.
Episodes 9 and 10, unsupervised learning. Clustering and dimensionality reduction.
Episode 11, capstone. One real project end-to-end using everything.
No skips. No shortcuts. Same approach as the Python series.
Episode 2 is the setup episode.
We install everything you need to run ML code in Python.
Python virtual environment. Pip, NumPy, Pandas, scikit-learn, Matplotlib, and Jupyter Notebook, where most ML code actually gets written. By the end of episode 2, you will have written and run your first ML line.
Not a hello world, an actual prediction. That episode drops next. Subscribe so you don't miss it. Machine learning is not about memorizing algorithms. It is about teaching machines to find patterns from data alone.
You now have the mental model. Everything else in the series builds on that.
Episode 2, setup, libraries, first prediction drops next.
Subscribe. Leave a comment. Tell me what part of ML you most want to build. I'm Majas. This is CodeToAGI. Let's build.